Okay, so I want to drive you through the same example, but instead of using moment matrices, we will be using um, sum of square relaxation of level 1 in our problem, which is f of amp of xy, such that x squared plus y squared is inferior to 1, and x minus 1 over 2 squared plus y minus 1 over 2 squared is equal to 1. So basically what we want to have is just xy minus lambda is equal to w plus the constraints, so plus alpha minus 1 xy stuff plus beta 1 minus x minus 1 over 2 squared plus y minus 1 over 2 squared stuff. And so w, we just have 1 xy for w, and so you can just like, because it's a it's like just like this, and q just q0, q11, q22, q12, q02, q01 multiplied by 1 xy. So we begin by doing this multiplication here, and it's basically equal to, and I wrote it here so we can see it after, just q0 plus q01x plus q02y plus q11 plus q12x plus q yeah, and so q01 is here too, so just basically we can directly write plus 2 q01x q00, and so we'll have like q and 2x stuff. Yeah, so it will be also, I'm just trying to wonder, like, because of the symmetry of the stuff, here, can I just not directly see that it's those terms that are stuff, doubling about it. So it's the q02y, so plus yeah, so it will be like plus, well, anyway, let's see, just like this, plus q01 here, plus q11x plus q12y plus q02 plus q 1, 2 x plus q to 2y. So yeah, that's it. And so raise it a little, q00 plus q01x plus q02y. And so we have this, and when we have this, we can multiply it. So by 1 xy, multiply by this, q00 plus q01x plus q02y, and here q01 plus q11x plus q12y. Here there is not a plus, just two separate lines, and here it's like q02 plus q1 to x plus q2 to y, which is just equal to q00 plus q0 on x, but it just gives us 2q0 on x plus q0 to y, but it will be like two steps, so it will be 2q0 to y, just like here, 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 and so plus q1 on x plus squared plus q1 to y squared xy, and so it will be the same at the bottom, so just 2q into y, 2q into xy, plus boom, 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 plus qy2 y squared. So if we had our constraints, it was like alpha multiplied by 1 minus x squared minus y squared, which is alpha minus x squared minus alpha squared minus alpha, just alpha, just alpha, there's no, the square is here, so alpha minus alpha y squared, and the second one, which is beta, was like 1 minus x minus 1 over 2 squared minus y minus 1 over 2 squared, and so just like beta of 1 minus x squared minus x plus 1 over 4 minus y squared minus x plus 1 over 4, which is just beta of 1 minus x squared, like just beta of 1 over 2 minus x squared minus y squared plus x plus y, and so if we factorize everything, we just get that we have like xy, have xy minus lambda, which is just equal to q00 plus alpha plus beta over 2 plus factorized by x, which is just 2q01 here plus beta plus alpha now, just plus beta. After we can go like to and so plus we have now so our stuff, we can take like xy potentially or y, so y multiply by 2q02 plus beta, now we can have like xy, which is just so we have this xy, So yeah, it's just like 2q12 plus, that's it normally, 6 squared multiplied by minus alpha, like q11 to be exact, like what, q11 minus alpha minus beta plus y squared of q22 of minus alpha minus beta, and yeah, so we have this. If we check the coefficients, then we have like so basically we have xy, which is the only which should be equal to 1 because here is xy, and it will be 0 0, but like so we have 1 because we have like xy equal xy of 2q1 over 2, so we can just simplify xy, and so we just get this, and so it just gives like 1 over 2 equal q12. And after for 0 0 1s, we just have like for example, like if we do in order, we have like if we do in order, we just have q00 plus alpha plus beta over 2 is equal to minus lambda. We have q01 equal minus beta over 2 because we have 2q01 plus beta equals 0. So same for q2, we just like minus beta over 2 goes to q0 plus beta. Yeah, we have like q1 equal minus alpha minus beta equals 0. So q11 is equal to alpha plus beta, and q22 is also equal to alpha plus beta. Yeah, so basically we have the step of so we say like it's like xy, and so our xy is just here, q00 plus alpha plus beta over 2, but it's minus stuff, so for having lambda we just have minus q00 minus alpha minus beta over 2, such that we have so it's the same matrix, like q00 being the same, q01 is minus b over 2, q02 is minus b over 2, q11 is alpha plus beta, q22 is alpha plus beta, Q12 is 1 over 2, and symmetrics is 1 over 2 here, is beta over 2 and is beta over 2. So we have this semi-positive definite with alpha being superior to 0. And yeah, we have this. So if you want to know why it's in condition alpha and beta, you just need to check the primal reverted. Like, alpha is written for this inequality condition, while beta is believing into error. But so yeah, if we know Lagrangian stuff, etc., if you remember, it's the same. Like with inequality, we put alpha being superior to 0, and for equality, we don't care, it will still be okay. It is into error to respect the essence of equality, so we need alpha superior to 0. And so for now we have this. And so now to determine the value, you need to remember that for a semi-definite positive matrix, this stuff like the sub-matrices should have also a positive determinant, etc. So basically we can take the one at the bottom that I'm quadrating here, which is like alpha plus beta, 1 over 2, 1 over 2, alpha plus beta. If we calculate the determinant of it, we have like alpha plus beta squared should be minus 1 over 4 should be superior to 0, which means alpha plus beta squared should be superior to 1 over 4, which means alpha plus beta should be superior to 1 over 2 by taking the square root of it. And so yeah, so we have alpha plus beta being superior to 1 over stuff, but so we serve the shop of it. We know alpha is superior equal to 0, so we fix it as 0. And because we want to minimize, we want the sub, we want to minimize minus alpha minus beta because to reduce the sub. So we just take it at 1 over 2. And so we just have like alpha plus beta equal 1 over 2. So we have just 1 over 2 here, 1 over 2 here. We can so beta is like 1 over 2, so just 1 over 4 here, and my alpha is 0, so we can suppress it. So if you check the lines, just like we have, and so here's minus 1 over 4, minus 1 over 4. And so if you check the lines, it's just like a multiplication of minus 1 over 2. Yeah, you do like minus 1 over 2. And so here it's just minus 1 over 4, and so here we do the same for having the same line, and so minus 1 over 8, and so Q0 is like Q0 is just like it should multiply by minus 1 over 2, so it gives 1 over 8, and so Q0 is just 1 over 8, and so it just the sub of minus 3 over 8, so that we have this. And so this matrix, we just need to show it's semi-positive definite, and we can write it as 1 over 2, multiplied by 1 over 2, 1, 1, 1 over 2, 1, 1, minus 1, minus 1, I mean. And so because of this, it just means she's semi-positive definite. And we can write, so our function is just xy and minus lambda, so it's just 3 over it, because we find lambda being minus 3 over it, so and so it's 1 over 2 multiplied by um, plus yeah, 1 over 2 of 1 over 2 minus x minus y squared, which is literally just this, and so alpha was 0, so we do not really care about it. But so after we have beta, so it's like beta normally is 1 over 2, beta which is 1 over 2 of what was inside, which tell us finally that xy, that so this is superior to 0 now, and so we just have xy plus 3 over 8 superior to, like, it's not superior to, but like, yeah, this is superior to 0, so how to say it, like, we do not really care about it, but like we have like xy is square root of minus 3 over 8 when x minus 1 over 2 squared minus y 1 over 2 squared is inferior to 1, because if this is inferior to 1, then we have this is positive. If inferior to 1, this is positive, and so we will just have like xy plus 3 over 8 is superior to 0, and it will mean that xy is superior to minus 3 over 8. Yeah, we have finished and have give the SOS decomposition here.